Good afternoon, everyone. Welcome to, I'm Steve,
And I'm Scott.
and together we're Backyard Musings, broadcasting Apple Valley. It's too windy outside. You probably heard from our segments, all the wind blowing, and it's still windy. So we're in our studio inside to broadcast.
Yeah, not only windy, it's kind of cool. We've lost our beautiful spring weather, so
Yeah.
it's just the way it is now.
So it was a fluke. We got a cold snap right now,
Yeah,
but it's not that cold. I mean, it's probably in the 50s.
yeah. Wind chill.
So we had a comment from Vagabond who said that the entanglement is instantaneous. When we did that segment about 13,000 kilometer quantum from a satellite from South Africa to China, and he said his comment was doesn't sound right because entanglement is instantaneous. So we're going to forward your question to the authors of the paper that did the research, those guys, and we're going to try and get a response. I mean, it's way above my head. It's definitely above Scott's head, definitely above my head. So we're going to do that.
Yeah.
Is that right, Scott? That's
or
what we
he
want to
could,
do.
or he could reach out to them, I guess. So all we do is just
Yeah.
articles that we deem interesting. We just talk about and pass on. And I mean, I know most of my comments are probably way off base as far as how this stuff is, because it's like you said, it is
Way off.
way over my head. So yeah.
So we'll ask the experts. We'll get back to you. All right. Got another quantum computing thing today. This one's really interesting. The University of Osaka Fujitsu Limited, Systems Engineering Consultants Company Limited, SEC, and TIS Inc. have announced the release of an open source operating system for quantum computers on GitHub. And we're going to talk about the open source at the end, but right now we're talking about this open source that they're making, this operating system they're making, named the Open Quantum Toolchain for operators and users. The acronym is OQTOPUS. This system represents one of the world's most comprehensive open source efforts in the field of quantum computing. The research was funded by the Japan Science and Technology Agency and the National Institutes for Quantum Science and Technology. Would you like to know more?
OQTOPUS is designed to be flexible and customizable, I guess, which is the acronym, right? Allowing users to tailor the system to their specific needs. Its release is expected to accelerate the practical deployment of quantum computing by significantly reducing the complexity of setting up and operating quantum systems, particularly in cold environments. So,
Cloud environments.
Is it effective or cloud environments? So is that a problem? Is it better on a clear day than it is on a cloudy day?
No. We're talking about in the cloud, like not physical clouds. So yeah. So these quantum computing needs its own operating software. So I guess they're starting it. They're being a pioneer in this, and they're going to start it and see if it takes off. Like there's IBM and there's iOS.
So there is evidence. There is evidence of my last statement about the issue from the other story, way over my head in the cloud. So,
all right. Previously, universities and companies had to develop extensive custom software to enable cloud-based quantum computing. With OQTOPUS, and again, that's spelled OQTOPUS if you're going to look it up. The collaborative team has streamlined this process by providing a complete, ready-to-use operating system from setup to execution, making quantum computing more accessible than ever before. And they had a diagram of how you diagram things like a flowchart kind of thing. And there was a user, there was the midstream, the back of house, and the back of house was extensive of how this operating system is working.
Okay. Additionally, the quantum computing cloud service offered by the University of Osaka has begun integrating OQTOPUS into its operations, and Fujitsu Limited will make it available for research partners using its quantum computers in the second half of 2025. Moving forward, the research team will drive the advancement of quantum computing through the continuous expansion of OQTOPUS's, or octopi's, I guess, capability and the development of thriving global community. Dr. Kisuke Fuji at the Center of Quantum Information and Quantum Biology of the University of Osaka mentions, quote, "This will facilitate the standardization of various quantum software and systems while driving the creation of innovative quantum applications," unquote.
Yeah, so octopuses with a contraction is possessive, octopi is plural. Okay, so I went to the website for Octopus, and I got their mission. The mission of Octopus is to form an open community for quantum computer science software and promote future technological innovation. Open sourcing will make it easier for various research institutes and companies to participate in quantum computer development and is expected to promote technological innovation and community formation.
I think I need to go back to school.
Well, now we get into a reason of why we need this.
Okay. And you've left that one up to me. Quantum computers operate on principles that differ drastically from classical computers, which present several challenges for quantum operating systems. Decoherence? You want me to read
decoherence.
that?
Yep, decoherence.
Noise. Quantum systems are highly sensitive to external influences, making them prone to errors. QCOS must manage and mitigate these issues to ensure reliable computations.
Right. So classical computing doesn't have this problem, but quantum computing does. All right. The next one is scalability. As quantum computers continue to grow and scale, now we talked about this before, Scott, when remember you had 512-bit and then 1024 and then 2048. It just kept scaling up and up as we, for communication speed, right? And now we're at terabytes, right?
Oh, yeah.
Back in the day, it was really small, like 512 was really, really small. So as quantum computers continue to grow and scale, the quantum computing operating software or system needs to be capable of managing a larger number of qubits, scaling up quantum operations while maintaining coherence and precision is a complex challenge.
Integration with classical systems. Quantum computing is not expected to replace classical computing entirely. As a result, QCOS must be designed to integrate seamlessly with classical systems to leverage hybrid computational models.
Yeah. A quantum computer operating system is a specialized software layer designed to manage quantum hardware, coordinate quantum resources, and facilitate the execution of quantum algorithms, while classical operating systems like Windows or Linux manage memory, CPU processes, and input-output tasks. QCOS needs to handle the unique challenges of quantum computing, such as quantum entanglement, coherence, and error correction.
The primary function of a QCOS is to bridge the gap between quantum software and quantum hardware. Here's how it supports quantum computing. Resource management. Quantum computers are composed of qubits, which must be carefully manipulated and maintained in specific states. A QCOS manages the quantum hardware resources, ensuring that qubits are correctly initialized, entangled, and measured during quantum computations.
Kind of think of it like our solid state hard drives and our non-solid state hard drives. Dang, the elders are calling me, man. They want to talk to me about something. So classical computers, they've got that solid state and the non-solid state hard drives. These quantum computers, same thing. Okay, quantum error correction. Due to the fragile nature of quantum systems, QCOS plays a vital role in managing error correction algorithms. These algorithms are critical to maintaining the integrity of quantum computations by identifying and correcting errors that may arise from decoherence or noise in the system.
scheduling and optimization. Quantum computing is inherently parallel, meaning many quantum operators can occur simultaneously. The QCOS schedules these operations efficiently, optimizing the execution of quantum algorithms and reducing the amount of time it takes to run quantum computations.
Yeah. So
I'll take the word for it.
I think this is fantastic that somebody is creating an operating system that they can all communicate rather than the universities, each university creating their own. Have a common one. You know what I'm saying? I think it's brilliant. This could be, we've got Apple, IBM, and now we got quantum. It's pretty cool. I think it's really cool.
And if I'm understanding this correctly, which I may not, and I'm probably not, quantum is a step above all those systems, right?
Oh yeah, much more data, much faster. Yeah.
Yeah. Okay.
Yeah.
So this will be the next jump, and then who knows what we have after that, right?
Yeah. I saw an article yesterday. I was thinking about writing a segment on it, but man, it was technical. It was about quantum computing, and actually, yeah, it was about the technology that could make faster chips, and it was like, oh, it was way over. I don't know that our viewers they'd just be bombarded with stuff that we don't understand. So I thought it was way too technical. So I passed it, just to let you know, Scott. But
Okay.
it looked interesting.
Speaking of chips, we're supposed to be starting a huge manufacturing plant here that would normally be manufactured in Taiwan, right?
Shut up. Really?
Going to be manufactured. Yeah. Trump introduced those guys the other day. Early on.
Oh, yeah. Taiwan was making an investment. That's here in California, or are you just saying the United States?
No. Here in the U.S.
Okay. Yeah. I remember that. I
mentioned, I want to say, and I could be wrong, but I want to say it's going to be in Arizona.
Well, Intel is in Arizona. There's some big fabs out there. Big fabs.
But that's going to be a good thing, right? That'll bring a lot of jobs.
Make it a technical hub. Yeah.
We won't be just dependent on a foreign country for that kind of stuff, which is good. So
thousands of jobs. Thousands of jobs.
Yeah.
All right, folks. Thanks for joining us. We'll catch you in the morning.
All right. Thank you.